Hello guys and welcome back at my channel. Today I would like to show you how to solve differential equations of the second degree or of the second order. And well, we're still working with a homogeneous case. That means the right hand side is equal to 0. So let's start. And you see that the approach right here is to assume that y is e to the power of some m times x. So somehow the second derivative, the first derivative, and the function itself must be canceling out at the end such that we get 0. So this is our assumption. We use the chain rule producing the derivatives. So this is the first one, this is the second one, and we're truly looking for m. So let's see what will happen. Well, we substitute it into our original equation. We have then the common factor, which is e to the power of mx. We can take it out. That means we use the distributive law. And if you remember, every product of two numbers can be visualized as an area of a rectangle. So if the area of a rectangle is equal to 0, then one of the side lengths must be 0. So it's either e to the power of mx or the parenthesis. And now you see e to the power of mx is always a positive value, so it's never 0. That's why only the parenthesis can be 0. And now we just have to solve a quadratic equation, which is way easier to handle than the previous question, right? The original question of the second degree differential equation. So using the ABC formula now, we are adding up at m equal to 1 right here, or m equal to 3 right there. And now we use the so-called superpositional principle. So we have kind of the first solution of this system of the differential equation, and now the second one. And if we add them up and add some constant c1 and c2 that are unchanged through the factor rule of the derivative, we're getting a total solution, which I called yt. So, and now the most important question is, have we really solved the equation that we wanted to solve? Is it really totally solved? And the answer is yes. So let's have a look. What will be the result right here? Well, we wanted to solve this one. And if we substitute now our given solution, would the end result be really 0? Let's figure it out. So y total prime is equal to 2c1 e to the power of 2x plus 3c2 e to the power of 3x, the chain rule for the first derivative. This is the second one. And now we're just plugging in into our original differential equation of the second degree. And now you see, if we put it all together and solve the parentheses and add that up, everything, we got 0 at the end. So our solution is perfectly correct. And this is how it's normally done for the homogeneous equations. You can think that, you can imagine that the non-homogeneous equations are solved the same way we've done homogeneous right now. So my next video is going to be an example where we solve maybe this kind of equation. Maybe we take the same equation, but we change the right-hand side. It's going to be non-homogeneous, but the approach, and this is mathematics, is pretty similar to what we've been doing in our previous videos. Okay? I hope you enjoyed it. Thank you, and see you in my next video. Bye bye.